Hey y'all, this is just a quick little video to show you guys kind of the key for this last assignment, just so if you guys were curious about the answers or if you guys want to see kind of my perspective and how I would phrase things, so that you guys have an idea of that. So hope you guys enjoyed the introductory video and the other videos I kind of posted. With this Bozeman science video, it's just kind of talking about the three kind of basic things that can happen to light. It can be reflected off that medium, so when light's going from one medium to another, say from gummy bear to gummy bear, from air to gummy bear, from air to water, from air to table, you name it. They can, or even from air to your eye, waves can, or electromagnetic waves can reflect off that medium. They can bounce off of it. They can be absorbed by it, or they can pass through it. Right. So those are the three things that can happen. When it's reflected, right, it's bouncing off that surface. If you remember, it comes in at a certain angle and it leaves at that same angle, right, on the other side of perpendicular. So it kind of comes in and comes at the same angle, and the energy is pretty much all contained in the wave still, right? It's not really transferred that much to the surface. A little bit is, but not that much. When light's absorbed, right, it actually comes into the medium and it's absorbed by the molecules and atoms that make it up. It's usually converted to heat, but sometimes it can be converted to another form. It can be stored in like the energy, like sugar in plants, right? That energy is actually being stored in that form. So it's not always just converted to heat. And then when things are transmitted, it just passes straight through. Sometimes it passes through like really clean. Sometimes it gets like a little bit scattered and like bounced around and changes direction. And sometimes it gets bent a little bit. That depends on the difference between the two mediums. But mostly the energy still ends up being contained in the wave. Just a little bit is transferred to the material. Right. So those are the three kind of main things that light waves or electromagnetic waves can do. Now looking more at color, I had you guys do this little reading. Pretty straightforward. Hope you guys kind of got a little bit out of it. But white light is just all the wavelengths of light together. Right? Once again, it's like those wavelengths don't actually have any whiteness, but our brain perceives them as being white, right? As not having any color. So that's white light, or rather having all the colors. And if we have like an object that's red, right? Let's say it's made of a material that has atoms and molecules that happen to absorb all wavelengths of visible light and only reflect red wavelengths. So that's why it appears red. Is as all those light waves together come into that object, all the light waves except for the red wavelengths are absorbed. Only red is reflected. That goes into your eyes, and that's why you see it as red. Right? So if you were to shine just the green wavelengths, if you're just to shine a green wavelength of light on that object, right, it's absorbing all those except for red. So it's absorbing that green, and the object would actually appear black, right? Which is kind of crazy. If we have white light shining through blue glass, it's kind of similar. We have this clear glass. It's actually, as the white light goes through, all the colors except for the blue are absorbed, and the blue is transmitted. It's actually allowed to pass through that glass, right? So that's why we end up seeing the glass is blue, is because only the blue light is actually passing through that glass while the other wavelengths are getting absorbed. Additive primary colors. These are colors that you can get by combining light, right? So if we have light sources that are kind of emitting these different colors, or producing these different colors, we can use those to add and create all the other colors. So these are red, green, and blue. And we can use those to make all the different hues of color that we kind of perceive with our eyes. The three subtractive primary colors are cyan, magenta, and yellow. I had one student put an interesting comment saying that they thought, like they learned in class, that, like when you're mixing colors, that it was red, blue, and yellow were the kind of primary colors that you might learn in like art class. And that's actually because it's harder, right? You get the yellow, but it's actually harder to get paints that are magenta and cyan. You don't actually see that as often for people mixing colors, but it can be used. You can use pigments that are red, green, or red, blue, and yellow. But ideally, right, you might want to use cyan, magenta, and yellow paints to like mix all of your colors. But these are the subtractive. They're pigments, so they rely on an outside light source. They're not producing their own light. And they absorb additive primary wavelengths. So for example, magenta absorbs green wavelengths. Right? So if I have a magenta paint, right, it appears magenta because from the external light is coming in, it's absorbing the green, right? And so red and blue are reflected. So I perceive red and blue together as magenta, right? So similarly, cyan dye absorbs red wavelengths, leaving blue and green, which gives me cyan. And then yellow absorbs blue, leaving red and green, which gives me yellow, right? So that's how that kind of works. So paints, dyes, and photographs, right? These rely on the subtractive colors, right? They rely on an external light source, and so they absorb certain pigments and reflect others, and so that's what's used in those, is those subtractive colors. And then screens, TVs, computers, phones, anything that kind of produce light on their own, right? They rely on these additive colors, right, to kind of trick our brains into seeing these different colors. I really hope you guys enjoyed this video. Stephen Mould he's really my jam. I don't know if you guys, I haven't really gotten any responses as to whether or not I should stop talking in an accent like that. But you know, I just think I might start doing that. It's kind of catchy, right? It feels a lot more intellectual, I'd say. But so there's 3 different types of cones in your eyes: the red, green, and blue cones. We could call those the long, medium, and short wavelength cones, but you'll hear red, green, and blue a lot. So your computer screen, or some kind of screen, if you're looking at that, it's made up of these little pixels. Each pixel has a red light, a blue light, and a green light that it can make. So when your computer wants to make yellow, for example, in those pixels where it wants to make yellow, it turns on the red and the green, right? And these go into your eye, those wavelengths. They stimulate the red cone a little bit. They stimulate the green cone a little bit. And that stimulation of the red and the green cone tricked my brain into thinking that I'm seeing a yellow wavelength, right? So I think that I see yellow, even though there's no actual yellow there. Right, now this is different from a flower. Outside, a flower takes white light from the sun, right, absorbs all the wavelengths except for the yellow wavelengths, right, reflects those yellow wavelengths towards my eyes. Those yellow wavelengths are absorbed a little bit by the red cone, a little bit by the green cone. So they stimulate the red cone a little bit, stimulate the green cone a little bit, and that makes me think that I'm seeing, and that tells me, you know, it's like I'm seeing yellow. That's what yellow is when that red cone is stimulated a little bit and when that green cone is stimulated a little bit. So that's how I see a yellow flower outside, but that actually has this wavelength, this yellow wavelength coming into my eye. Whereas a computer screen, there's no yellow wavelengths actually entering my eye. It's kind of a trick. All right, but they are similar in that my green cones and my red cones are both stimulated a little bit in just the right amount to make my brain process this as seeing yellow. In this last piece here, I hope you guys enjoyed it. Step 5, I didn't have it here, but I had the answers there. I hope you guys enjoyed messing around with that. But this process here is called photosynthesis. The molecule is chlorophyll. There's a couple of different types. But if you remember, it absorbs a lot in the red and the orange, and then absorbs a lot in the blue and the violet. Right. So the student doesn't understand because we're seeing green on a plant. That means that we're seeing the light that's reflected, right, and not absorbed. Right. All the green is actually not used in photosynthesis. That's the red and the orange and the blue and the purple. And so the green is actually reflected. So what they should have said was that the plants are green because they reflect green light, while using red and blue light, those are absorbed and used for photosynthesis. So that's that. I hope you guys enjoyed this, and I'll see you guys later.